Hello all, in today's lecture we'll be studying about half adder. What do you mean by half adder? Half adder is nothing but a normal arithmetic addition of 2-bit numbers. It's done using a half adder. Fine. This is again an example of a combinational logic circuit. In today's lecture we'll be seeing how to design a half adder using a combinational logic circuit. Fine. For a half adder you'll be having two inputs. That is, I'm taking my input as A and B. Fine. I'll be getting two output. One is the sum, the other is the carry. I'm going to represent sum with S and carry with C. These are my two outputs. Clear? For two inputs. If you have two inputs, how many combinations are possible? 2 power 2, it is 4 combinations. Right? The number of combinations that you have for two input, it is 4. Since we know how many inputs are there, how many combinations are possible, can we do the truth table now? Yes. This is my input and this is my output. How many inputs are there? I've got two inputs, A and B. Right? And how many outputs are there? One is sum, one is carry. I've got two outputs also. For two inputs, I know how many combinations I'll be having. I've got 4 combinations. So write down the combinations. It is 0, 0, 0, 1, 1, 0 and 1, 1. And how do you find a sum? I told you half adder is nothing but the normal addition of 2-bit numbers. Fine, that will give you the sum. So 0 plus 0. I've got two inputs here. So do the addition of both the inputs. So 0 plus 0, it is 0. And do I have a carry here? No, I don't have a carry. Do the addition. 0 plus 0. This is A and this is B. Fine. 0 plus 0 is 0. This is my sum. Do I have a carry? No, I don't have a carry, so I put 0 here. The next number, the next combination, 0 plus 1. 0 is for A and 1 under B. Fine. 0 plus 1. What is 0 plus 1? It is 1. So my sum is 1. Do I have a carry here? I don't have a carry, so I'll put 0. Clear? The next combination, 1 plus 0. 1 plus 0 is what? Again 1. Do I have a carry here? No, I don't have a carry. My sum is 1. So sum is 1, carry is 0. Clear? Now, 1 plus 1. 1 plus 1 is what? 10. 1 and 1, when you add, it is 10. So, this is my carry. Right? So, my sum is 0. This is my sum. And this is my carry. So, against sum, I'll be giving 0. And against carry, I'll be writing 1. Is it clear? How to write the truth table for a half adder? Now, after finding the truth table, what did we do in the design procedure? After finding the truth table, you have to take your output to your K-map. We have got two outputs. So, we'll be having two K-maps. One for sum and one for carry. Now, let's do the K-map. Whatever output you have got two outputs, so you'll be having two K-map. And how many variable K-map you'll be having? You have got two variables, so you'll be using two variable K-map. This is for sum output, and I have another output, that is carry. This is for my carry. Clear? Now, find wherever you have 1, write the decimal also. Fine. So, take out the sum input alone. I am considering only the sum input right now. On the sum input, wherever you have 1 in the output, against those numbers, you have to mention a 1 in the K-map. So, where do I have a 1? I have 1 against 1 and 1 against 2. So, against 1 and 2, I'll be positioning 1. Clear? By default, everything is SOP. Fine. So, I'll be mentioning 1. Now, can I do a mapping here? No. So, I have to do only single variable mapping. Now, after doing the mapping, give me the equation. It is what? This is A bar, this is A, this is B bar, and this is B. Give me the equation. Sum is equal to, for this bubble, it is A, B bar, and for this bubble, it is A bar, B. Right? What gate is this? You should be able to say by now. If you have seen my logic gates lecture, you will be able to say this. The entire combinational logic circuit chapter is based on designing part. So if you have not seen it, kindly refer to the lecture to get a strong hold on what gates are, what are the different type of gates, what is the formula, what is the symbol, everything. I'll give the link of my logic gate lecture in the description. Kindly refer to it and then come back so that it will be easy for you to solve. Clear? Now, give me the expression for carry, for against carry. Let's take carry. For the carry output, where do you have 1? You have 1 only against 3. So, only against the number 3, you will be mentioning a 1. So, there is only a single variable mapping here. Now, give me the expression. It is A bar, it is A, this is B bar and B. So, what is the output for this? What is the expression? It is A into B. Clear? Now, after finding the expression, what is your next step in the design procedure? You have to design the combinational logic circuit based on the logic gates. Now, design. How many inputs are there? You have got 2 inputs, A and B. Let's design the circuit for sum first. Sum, what gate is this? This is XOR gate. So, how do you draw the XOR gate? XOR gate will be drawn like this. Clear? What is the output of XOR gate? This is A XOR B, which is equal to the sum. Clear? We have got the sum now. In a similar way, you have to draw for carry as well. So how do you draw the carry in this logic diagram? Carry is nothing but the product of A and B. A, I have it here. B, I have it here. Both you have to do a product. For product, which gate you will be using? You will be using an AND gate. So A and B. Product of your input is going to be your output of the AND gate. And this is nothing but my carry. Clear? This is how you will be designing a half adder. Is it clear? Where do you use this half adder? Can you give me some applications where you'll be using the half adder? You'll be using half adders in multiplexer, in designing multiplexer, demultiplexers, encoder, decoder, and all the arithmetic circuits will be based on adders. Clear? These are some of the few applications of where you'll be using a half adder. Understood where you'll be using a half adder? Half adders are mainly used in the multiplexer, demultiplexer. Almost all the arithmetic circuits will be making use of half adder, because half adder is nothing but the addition. Wherever you feel like there is some addition that has to be done, then half adder is by default it will be used there. Clear? I hope you're clear with this lecture. Let's sum it up. In this lecture, we saw about what a half adder is, where you'll be using the half adders, and how to design a half adder based on combinational logic circuit, for which you have to identify the input to a half adder. We have, half adder has got only 2 input and 2 output. So within the 2 input, how many combinations are possible, we'll know. And with that, we'll be designing the truth table. From the truth table, both the outputs you'll be taking into the K-map separately. You'll take the simplified Boolean expression from the K-map. After taking the expression, you'll be designing a circuit using logic gates. Is it clear? This is what we have seen in today's lecture. I hope you're clear with half adder. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.